The purpose of this screencast is to learn about periodic groups and Lewis dot diagrams. During this screencast, write down the notes when discussed, pause the video when needed or wanted, and rewind when wanted. So if you are confused about information and you need to hear it again, just go ahead and pause it and rewind. If you have questions, also raise your hand and Mr. T, Mr. Lewis, or Miss Stott can come and help you. There are 5 different categories of the periodic table: the alkali metals, the alkaline earth metals, the transition metals, halogens, or noble gases. You should be writing this information down on the notes that you picked up on the way in. We're going to talk about the differences in the groups, where we can find them, valence electrons, and some example elements for each. This is a picture of the categories or groups that we just discussed. As you can see, the alkali metals are over on the left side of the screen. Next are the alkaline earth metals. The transition metals are a big group in the middle. The halogens, and then the noble gases. Although these elements right here are important, they don't fit into the different groups that we're going to talk about today. So these groups or categories have a few things in common. They have the same group numbers, valence electrons, and chemical and physical properties. So valence electrons are what we talked about yesterday with Bohr models. They are the electrons found in the outermost shell of an atom. The outermost shell is the outside shell of a Bohr model. As you can see here, this atom has 8 valence electrons because that's the number of electrons that are in its outside shell here. Valence electrons tell us how different elements react or behave. So they are extremely important for reactivity and a lot of the different properties that we've talked about before. So physical and chemical properties come from the number of valence electrons that different elements have. This is a table of the periodic table categories or groups, and we're going to talk about the different groups and what we can find there and what kind of similarities they have. So group 1 are called the alkali metals. So everyone in group 1 is an alkali metal. Since they're in group 1, they have 1 valence electron. The group number actually tells us the number of valence electrons. Examples of elements in this group include lithium and potassium on your periodic table. All of these elements have the same things in common in terms of properties. They have low boiling points, low melting points, and are highly reactive. Group 2 elements are called the alkaline earth metals. Because they are in group 2, they have 2 valence electrons. Examples of elements in this group include magnesium and calcium. These elements are harder and denser than the group of alkali metals. The middle section, groups 3 through 12, are called the transition metals. This is the only group that we're going to talk about today that consists of more than one group. Since the number of valence electrons are told to us by the group number on the periodic table, the number of valence electrons for the transition metals are going to vary or change depending on which group they are in. Examples of elements in this group or category are iron and gold. They have high boiling points and high melting points as well. Group 7A are called the halogens. Because they're in group 17, also known as 7A, they have 7 valence electrons. The number of valence electrons that an element has can only be up to 8, like we talked about yesterday, because of the Bohr model shells and how many electrons they hold. Examples of halogens include bromine and chlorine. These are nonmetals that are highly reactive. Group 8A or 18 are called the noble gases. The number of valence electrons in group 8A or 18 are 8, which is the most number of valence electrons an element can have. Examples of these elements include neon and argon. The properties include the fact that they are odorless and colorless gases. So everyone that is a noble gas is a gas. Now we're going to be discussing Lewis dot diagrams. Lewis dot diagrams are a little bit like the drawings of the Bohr models that we saw yesterday because they show electrons around the atom. The difference is that Bohr models that we saw yesterday showed all of the electrons in an element as well as the protons and the neutrons. Today, our Lewis dot structures or Lewis dot diagrams are going to show only the valence electrons of an element, which again are the outside shell electrons. The total number of valence electrons, like I said before, can only add up to 8 because it's told to us by the number of electrons in that outside shell of the Bohr model. This is a picture of various Lewis dot diagrams like you saw in the vocabulary video last week. All of these different Lewis dot diagrams are actually told to us by their groups, which we're going to be talking about today, and these are just some examples of what our Lewis dot diagrams that we'll be drawing today will look like. In order to create Lewis dot diagrams, we need to follow a couple steps. The first step is to locate the element on the periodic table. We need to know what group it's in, so we want to find it on the periodic table first. Once we've done that, we're going to determine how many valence electrons there are in the element based on the group number. Again, reminder, group number 1 has 1 valence electron, group number 2 has 2 valence electrons, and so forth. The only ones that we're not going to be drawing Lewis dot diagrams for are going to be our transition metals, and that's because they have different numbers of valence electrons. So, for example, carbon is in group 14, or 4A, so it will have 4 valence electrons. As you can see in the drawing over here, carbon has 4 different valence electrons. What we're going to be learning today is how to actually draw those dots in the correct order. So we're going to draw the electrons in as dots. So since carbon had 4 valence electrons, it had 4 dots. In order to do this, we need to place 1 dot at each side, and then we're going to pair up the spots that we already had with another set of dots. This is called the cross method, and we're going to go in depth into the cross method next. This is example 1, which is Ba or barium. First, when we're going to write our Lewis dot diagram or draw our Lewis dot diagram, we need to make a cross over our element like I've done here. Go ahead and draw that cross on your paper over the Ba. You want to make sure that it's centered in the middle, like you see, where it's right down the middle of the B and the A, and right down the middle of the B and the A the other way as well. Then we're going to draw in our numbers. These numbers are going to be the order at which we draw our dots. 1 is going to go up in the top right corner. Then we're going to skip over 1 spot to draw our 2 over in the next corner. Then we'll draw our 3 and our 4. So notice there's 1 number near each line. Once we've drawn all 4, and if you notice we're going in a counterclockwise direction, or the direction opposite of the clock, then we're going to draw our next dot, number 5, up near my 1. Number 6 is going to be near my 2. Number 7 will be near my 3. And number 8 will be near my 4. This is the way that we will label our diagram and then also draw our dots in. The next thing we want to do is look at Ba and what group it's in. Ba is in group 2, which, as we learned early, are the alkaline earth metals. If barium's in group 2, then how many valence electrons would it have? 2 is correct. So I know this is getting cut off a little bit, but number 2 would be the number of valence electrons. So So you can write that on your paper. So then we're going to actually draw our dots. The first dot is going to be drawn in the spot where the 1 is. So I'm going to draw my dot there. You can draw your dots a little bit smaller than I did, but you want them to be bigger than a pencil point. So you want to kind of make them a little dot like you would dot an I. Notice that the dot is not right up against the barium. It's outside of the entire barium, as if barium had an imaginary box around it. Also, the dot is close to the 1 and close to the barium as well. So we don't want to put the dots all the way out here. We don't want to put them on the actual drawing of the BA either. The next dot is going to be near the number 2. So it's very close to the BA. It's not all the way out to the 2 or over here in the corner, but it is not overlapping the BA. And that is it. That's our Lewis dot diagram for BA, which shows that it has 2 valence electrons because it's in group 2. For our second example, we're going to look at neon. We're going to start off our Lewis dot diagram in the same way that we did it before. We're going to label our numbers on our cross. So we're going to draw our cross right down the N and E, and then right across the N and E as well. And then we're going to draw in our numbers. So number 1 again goes up in the right hand corner. We skip a line and go to 2. We skip and go to 3. And then we skip to 4. So there should be a number near each line. Then we double up. The 5 goes near the 1, the 6 goes near the 2, the 7 goes near the 3, and the 8 goes near the 4. And again, we're moving in a counterclockwise direction against the clock. Then we're going to look at neon on the periodic table. It's all the way over on the right side in group 8. So this is group 18 or 8A. Most likely you'll hear it referred to as just group 8 or 8A. Then, the name of it are called the noble gases, as we talked about before. And lastly, the valence electrons are going to be 8 because the group is 8A. So there are 8 valence electrons. Then we're going to go ahead and put our dots in. We're going to start dot 1 near the top right corner where 1 is. Notice it's outside of the NE and it's not up here in the corner. Our second dot is going to be here near the 2. It's not near the 2 as far as on top of the 2. It's closer to the NE, but it's near the 2 spot. The next dot is dot 3, dot 4. Then we're going to double up to go to 5, 6, 7, and 8. Notice that the dots look like a circle around NE rather than a real big box, but none of the dots are overlapping onto NE, none of them cover up the letters of NE, and none of them are all the way out by near the numbers or in the diagonal region. This is how we want to draw our Lewis dot diagram, which will become very important when we talk about bonding later. So things to remember when you go to draw these Lewis dot diagrams. 1. Elements can have up to 8 valence electrons, so Lewis dot diagrams should only have up to 8 dots. A common mistake is for people to draw the number of dots as true electrons versus valence. Then, please place 1 dot at each corner before you double up and draw the dots again. And lastly, each element in a group on the periodic table should have the same number of valence electrons and therefore a similar dot diagram. So everybody in group 7 will have 7 dots, everyone in group 8 will have 8 dots, and so forth. Good luck!